Hello friends, in the last session we have seen how this keyword you can use, and we have noticed that this keyword can be used from a static context only, and you cannot use this keyword from a instance context. This keyword cannot be used from static context, and you can access only from the instance context, right? And in this session we are going to see the use of this keyword and where exactly you need to use this keyword. And in the last session we have seen that this keyword refers the current object, right? The current object, on which object you are calling a function, on that only this keyword points, right? And inside the JVM memory, how this keyword memory gets allocated in all the stack frame, and how it points to the current object from each stack frame, right? Now this keyword definition is, this is a final, right? This is a final reference variable. And how will you prove that it is final? Say you have a class ABC, and in that, say you have a method void m1 is a method, right? This. Now from class test, so you have a class test. Inside the test class, the main method main, right? One string type, one dimensional array args, right? So in this, if I want to call the m1 method from ABC, then I need to create an object of ABC first. So this is ABC, a1 is new ABC, right? Then I will call a1.m1 function. Then inside m1, here you have this, you get this here, and this points to the same object where a1 is pointing, right? And this is final. Final means, final variable, we already know that if a variable is say int x is equal to 99, and after some time if I say x is equal to 88, it is valid. This means when x is equal to 99, x memory is allocated somewhere and the value of x is 99. Again, when you reinitialize the value of x with 88, then the value of x becomes 88, right? But if I don't want like this, I don't want that x, once it is initialized, it should not be reinitialized, then you can say it is final, right? Final. When you will write final int x is equal to 99, then this is valid. First time it is 99, okay. And second time when you will say x is equal to 88, then this statement gives a compilation error and it says x is already initialized with 99, and again you cannot initialize that with 88. So this is the meaning of final variable. When a variable is final, it means it cannot be reinitialized once it is initialized. So same way, this keyword is by default final. This is by default final, and this gets initialized automatically with the current object reference, right? This gets initialized automatically with the current object reference. So once it is initialized with the current object reference, you cannot reinitialize it. Now, what is the type of this keyword here? Type of this keyword. Suppose if I have a reference variable ABC, A1 is a reference variable, and A1 is supposed to point to an object, then that object must be of type ABC only. ABC only. What is the meaning of this statement? A1 is a reference variable which is of type ABC, and it is pointing to an object, say 1020 is the address, and here it is 1020, and A points to this, right? Then the object type is ABC, and the reference variable is also of type ABC, right? So the reference variable and the value and the object, here you can say, and the object, or here x is of type int, and this 99 is also of type int. So the variable and the value must be exactly same type. Here x and 99 both is of type int. Here a1 and abc of type abc. A1 and object, this object, right, is of type abc only, and then only a1 can point to this object. If I have one more class, say class sum x y z, is a class. Now if I write here ABC A2 is equal to new x, y, z, then this gives a compilation error. Why? Because when you are creating this ABC A2 is a reference variable of type ABC, and when you are creating the object is of type XYZ. Now A2, which is of type ABC, cannot point to an object which is of type XYZ. Now if you want to hold the address, or if you want to hold the reference of this object, then you need to create a reference variable of type XYZ itself. So you can say XYZ, say X1 is equal to new XYZ. Now what happens? X1, one memory is allocated, and an object is also created of type XYZ. Both is of same type, and the address 1040, this X1 can point to this. The reference variable and the object must be of same type. The reference variable and the object must be of same type. So this statement is not valid. This is A1, object is of type ABC. A1 is also of type ABC. X1 is of type XYZ, and object is also of type XYZ. Or if I write like this, A1 assignment operator X1, means X1 I am trying to assign into A1, right? X1 is pointing to an object which is of type XYZ, and A1 is a reference variable which is of type ABC. Both is two different type. A1 is of type ABC, X1 is pointing to an object which is of type XYZ. So X1 is of type XYZ, this is of type XYZ, and A1 is of type ABC. So this assignment is not possible, you cannot do. So this is also a compilation failed. Now from here we understood that the variable, the reference variable, and the object where it points must be exactly same type. Otherwise this is not possible. A different type reference variable cannot point to a different types of object. It must be exactly same. Now come to this M1 method. When you call A1 on M1, then A1 address is stored into this keyword here. Now say this is A1. A1 is pointing to this ABC object, and the object address is 1020. Means this value is also 1020. Now this is here a reference variable. Somewhere here this is there, a reference variable from the M1 method, and this is also pointing to the same object 1020. Now it means that these must be of type A. Now this inside the M1 method, this is of type ABC, and when you call M1 you have to call on a reference variable of type ABC only, right? So this type and ABC type is exactly same. Now if I take, say, another example, so you have one more class so you have a class XYZ, and in that you have void, say, M2 function, M2. Then when you will call M2 function with any reference variable, inside M2 also you will have a this. Now these inside M2 is of type XYZ only, right? XYZ only. Now if I try, say, that this keyword always is of type current type. So if I have a class A, and inside this A somewhere I have a method, say some method void show method. Inside the show method, if I have a this, then this should be of type A only. Or if I have a B, say class B, I have a class B, and inside B if I have a method void disp. Inside disp I have a this, and this is of type B. So this is always of current type. Inside which class you are using this keyword, this is of that class type only. Okay, this is always of current type. So from this discussion we understood that this is of current type. But this is final also, right? This is final. How will you prove that? Suppose if I have a class, something like this. Some class hello, hello. Now inside the hello class, say I have a method void m method, and I have class test. In test class I have the main method void main. Right, in that I want to call this m method of hello, then I need an object. So hello h is equal to new hello. When you say like this is h is a reference variable of size 8 byte. It points to an object of type hello. The address is say 1020, this is 1020, this points here. Right, now when we will call h dot m, inside the m also you have a this, and this value is 1020, means this is also pointing to the same object where m is pointing. Now in this type is of type hello and h is also of type hello, both is of same type. Now in this, if I take another, say hello h2 is a reference variable, and if I assign here this, what is the meaning? This address you are storing into h2. So now here you have one more reference variable h2, and h2 also starts pointing to the same object where h1 is pointing, or where this is also pointing, right? This is also 10. This and h2 is from m method of hello class when you call h dot m, right? So this is to prove that this is always of current type. Or suppose if I say like this is fine, this statement executes successfully, it is okay, no problem. If I say I have one more class, say hi, I have a class hi. Now here if I take a reference variable hi, h3 is equal to this, Now what will happen? This is of which type? This is of hello type, where I am assigning that to h3 is of type hi. This of hello type cannot store into hi type, this is not okay. So this is compilation failed, incompatible type. So this is to prove that this is always current type. Because of that, this when you are assigning to h2 which is of type hello, it is okay. But if I assign this to h3 which is of type hi, this is not okay. But if I do a little more modification on this, say if I write a class like this, say I have a class some ABC. Inside ABC class I have void m1 function, and I have a main method somewhere. So class test which is having the main method public static void and main. Inside the main method I want to call m1, then I need an object abc, a1 is equal to new abc. Right, now if I say a1 dot m1, now a1 is a reference variable which is pointing to an object of type abc. The address is 1040, say 1040, right? Now inside m1 you have this is also pointing to this is 1040, right? Okay, before to that, if I write something like this, so this is a1 and new abc a1 dot m, this is pointing to this location, right? Now if I say a1 is equal to new abc again, now what happens? This new abc creates a new object. One new object is created inside the heap, and the address is a 2080, and now this object address is assigned to a1. Now the address of a1 is not this, it is 2080, and a1 starts pointing to this, it is not pointing here, right? Now a1 reference variable value is changed, and a1 which was before pointing to this object, now a1 is pointing to this object. You can do that because the object which you have created here with new abc is of type a1. Object is of type a1, and the reference variable is also of type a1. So one reference variable before which was pointing to other object before, now it is pointing to a new different object. Now if I do the same thing with this keyword, say this statement is not here. Now when we will say a1 dot m1, a1 points to this object at that time, and this also points to the same object. Now this is also a reference variable, so what I will do is this is equal to new of ABC. If I write like this, what is the meaning? You are creating an object of type ABC and the address you are going to store into this. But this is by default final. You cannot change it. Once this is initialized, it is by default final. Now here you are calling first time a1.m1. Then m1 is a method is loaded inside that this keyword came, and this keyword is started pointing to the same object where a1 was pointing. So it was pointing into this object. Now when you will say this is equal to new ABC, it means you are creating a new object, and the new object address you are assigning to this keyword means you have created a new object and the address is say 8040. This has to store into this 8040 and this starts pointing into this, but which is not possible because this keyword is, sorry, it is not A1, it is this keyword always final. It cannot, it is always pointing to this, it cannot point into this object, right? This is a final variable. So in this we have seen two things. One is this one, very very important. This is always of current type. Next, this is of final type, right? This is always a current, it is a reference variable. We have understood here that this is a reference variable because it points to the current object, and any variable which holds an address of an object must be a reference variable. So this is a reference variable. Next, this is current type. This proved by this because this is giving here a incompatible type error, compilation fail, right? We are going to see that with the program. And next, this is final. This is going to prove by this statement. This is of type ABC, okay, it is current type. And next, this is final, because of that this cannot be assigned to this keyword. One new object you cannot create and you cannot store into this location because this is always final reference variable, right? Now let's see that with a program. So I'll take a different test here. Test 1, and in package say p7. Take a main method and click on finish. Now first you take a class ABC, and ABC you have void m1 is a function, right? M1 is a function. Now inside m1 I'll just print here that it is m1 function in ABC, and m1 I want to call. Then ABC a1 new ABC, right? And a1 dot m1. This is normal call, so the output should be m1 in ABC. That's it. Run this and test first, right? It is m1 in ABC. Now if I check here, if I print a1 and here if I print this, then both should be same. This is already have seen in the last tutorial, so both is same. Next, if I write one more class, say here class, or before that if I take here one more, say ABC a2 is new, sorry not new, it is just this, right? This. And if I print here a2 also, then this a2 and a1 from the main all is pointing to the same object, so the output is same, right? But here if I do like this, say a1 is equal to new ABC, and after that again if I print a1, and here I'll draw a line, right? So here you check the a1 first, so this is a1, and here also I'm printing a1, right? This a1 at this point here ABC object is created, a1 is pointing to this, m1 function is called, and inside m1 function this is pointing to this object, and even this is assigned to a2, so a2 is also pointing to the same object. So till this the output of a1 and the output of this and the output of a2 is same. But after that, when you have assigned a2, sorry, another new object to a1, then a1 is pointing to a different object. Now the a1 value is different. Now you check a1 value. Okay, save this and print. Right, so this is, now it is different because now a1 is pointing to a different object, right? A1 is pointing to a different object. And so same way here, what we did, this we have assigned to some other reference variable and it is pointing to a different object. Now what I will do is, if I take a class some xyz is a class. Now here if I create an object of xyz, x1 is equal to new xyz is valid because x1 is of type xyz and object is also of type xyz. So this is a complete valid statement, no problem. But if I write like this, so xyz x1 is equal to a1, it is a compilation fail, incompatible type. Okay, it is incompatible type. You cannot store a1 reference variable to a1 object to xyz because x1 is of type xyz, right? So this is uncommented. Now here if I do the same thing, suppose if I take xyz x2 is equal to this, that is also not okay because this again incompatible because this is of type abc and x2 is of type xyz, so this is incompatible. So this is to prove that this is always of current type. If I say here this, it is of type abc, but inside the xyz, say if I have a method void m2 and if I try something like this xyz, in m2 also you have a x, sorry, you have a this, right? So in this if I try x, so 3 is equal to this, fine, because this inside xyz is of type xyz and x3 is also of type xyz, so both is same type, it is okay. Reference variable and the object is of same type, so it is fine. But here if I take an abc a3 is equal to this, now this is not okay because here this is of type xyz and in this is of type abc, so you cannot store into xyz, and this is of type abc, so this you cannot store into sorry, here this is of type xyz, so you cannot store into abc, right? So this is commented. So this is always of current type. So from this you understood this is a reference variable which is of current type and which points to the current object. And next it is final. This I have assigned to abc, okay, fine. But what I'll do here is, if I say this, if I reinitialize with the new abc object, not okay. Now it is saying that this is a final and you cannot assign a value to that because it is final. This is always a final reference variable. You cannot assign other object to this once it is initialized. So here also if I say the same thing, say this is this equal to new xyz, and this is also not okay because this is final. So from this complete we understood that this is a final reference variable of current type which points to the current object, right? This is a final reference variable of current type which points to the current object. So now this is fine. Next is this this from this now next is what is the use of this keyword and how many ways you can use this keyword, right? How many ways you can use this keyword. So use of this keyword we are going to see in next tutorial. Thanks for watching my video. Please subscribe for more videos.